Yes, I welcome you all for another pleasant and beautiful presentation on our beautiful subject signals and systems. In today's presentation, just I would like to bring forth you about the classifications of systems. So far, we have seen the various types of signals and then some elementary signals also we have seen in the last presentation, whereas in our previous presentations if you refer, right? So in this today's presentation I would like to explain you or bring to your knowledge that what are the classifications of the system. By the way, today we are going to see the lecture number 12 on signals and systems subject, right? So let us see what are the classifications of systems. Okay, classifications. What are the classifications of system? Before this, just I would like to define what is a system in general. So classifications of systems we will see, but before going to see the classification, what is a system first? What is a system? Very important definition. So a system is defined like this: any physical device you can call, so this can be represented basically like this simple box you can represent, right? It has certain output, and then normally you can call it as some y of n or y of t, and it has certain input. This is what your input, normally it is x of t, and it is any physical device. Normally, okay, you can call it as physical any physical device. This we are calling it as a system. In bracket I can write, like, no problem, nothing wrong in this, right? So what is a system? System is nothing but any physical device which performs various operations on the given input in order to get the output. That particular device is called a system. A system can be interconnection of so many, subsystems. Maybe if you refer any electronic circuit, in any electronic circuit or some in like your VLSI circuit, very large cell integration, or any circuit, any IC, you can say any integrated circuit, it is a combination of multiple sub circuits will be there, like amplification, oscillators, and then there are so many things actually it will performs. That's why so all together it is called a system. So depending on the requirement, depending on the application, that particular system will give the respective the desired output depending on the requirement of the system, right? In brief, in general, in short, we can define like this: any physical device which performs certain operations on the input in order to get the desired output is called a system. And remember that here input is obviously denoted by the letter x of t, and always remember that your t, small t, stands for it is for a continuous time. Always remember t stands for continuous time. Therefore, your x of t is a continuous time signal. As well as here, if you see, y of t is nothing but the output of this particular system. Again, t is the continuous time. So now we are describing, or we are saying about the continuous time system. Similarly, the same can be defined, or the same can be applicable in discrete time also. In a discrete time, only the thing is the x of t is denoted with x of n. That's it. X of n, as well as your y of t is denoted with y of n. The representation of time, where n is the discrete time, remember it, whereas t is a continuous time. That's it. T is is a representation of a continuous time, as well as your n is a representation of a time for discrete time, right? So remember that. Similarly, here your input is called as, sometimes it is called excitation, more some okay, excitation. Sometimes your input is also called as excitation, whereas your output is also called as your response. Your response. Your response. That is what the simple definition, okay, as far as system is concerned. Therefore, a system is any physical device that performs certain operations on the input in order to get the desired output. That is what a simple definition of a system, right? Now, what are the various classifications of the system as far as our subject is concerned? With respect to our signals and system, what are the various classifications? There are some classifications are there. We can see one by one in detail. The number one is static and dynamic. Static versus dynamic. Static versus dynamic system. Clear? That is the first classification of the system. And the second one is that linear and then linear versus non-linear. Linear versus non-linear system. This is the another classification of system. And the third one is linear time variant. Very important. Linear time variant, that is LTV, linear time variant versus linear time invariant. Linear time invariant. Linear time invariant, that is LTI system, right? Very important system. And the next classification is that causal system, another very important. CAUSAL, causal versus non-causal. Causal versus non-causal system, right? And then stable and then unstable. The final almost all is stable and then unstable or non-stable, you can say. Unstable system. Basically we will have, these are the various classifications of the system. Clear? Static versus dynamic, linear versus non-linear, linear time variant versus linear time invariant, causal system and a non-causal system, stable versus unstable system. Each of these classifications are very important classifications. Clear? So both as well as in our GATE examination as well as in IAS examination point of view also, even in our academics also. Therefore, every classification is very important. In fact, they are very easy to understand. Nothing to, difficult to understand if you understand it clearly. If you understand the meaning of it very clearly, definitely it will be very nice. Then let us see at least one or two in this presentation, and we will see the remaining in the subsequent presentation. Let us see what is a static and then versus dynamic. What is a static versus dynamic? What is a static system? What is a dynamic system? Right? Static system. The first classification is static. Static versus dynamic. In the name itself, it implies that the static system, as the name itself implies, that static means it has no movement. Static means it has no movement actually. Static means it remains constant. Static means it remains constant. There is no movement at all. It remains constant. That's it. And moreover, it will at relaxed condition, at initial condition, at relaxed conditions means at t equal to 0. Okay, at t equal to 0 means always the position of the system is at t equal to 0 itself. It will not move. That is what the static. Whereas dynamic is not like static. Dynamic means it is opposite to the static. Therefore, as far as our subject is concerned, there is another name for static system, is that this is called the system with memoryless system. Static system also called as memoryless. Remember it, memoryless. Static system is also called as memoryless system, whereas the dynamic system is called the system having memory, the system with memory, or the system having memory. System having memory. System having memory. Dynamic systems are called systems having memory, whereas the static systems are called the systems with no memory or memoryless systems. Right? Then what is the actual definition of this? What is the actual definition of this? The actual definition of this particular static versus or dynamic system is nothing but, okay, so again, always remember that in academic point of view, you have to explain by using this block diagram. Means, as I have explained you just now, you just always remember, you just explain each and every definition of your system you must use like this, and then you have to explain. So this is what your input basically, as I already just now explained you, x of t, this is your y of t. Actually, this is what I am calling it as a system. This is what my system basically. What is the static means? The static means that, let us say, a continuous time system. Here always remember that my input and then output both are with continuous time only. They are functions of continuous time only. Therefore, this system is called a continuous time system. It is a continuous time system. So, how we can define a continuous time system is called a static system. Static system, or the system with no memory, if its output y of t, at any instant of time t, okay, depends at most on the input signal at the same instant of time, but not on the future or past input of the input values. Clear? So means that your y of t means this is the present time t, whereas this is the present time of input, present time of output. Okay, so what is the past input? I will explain you very little now, and I can explain you in elaborate in the subsequent presentations while solving the problem, and while we are discussing the subsequent topics, you will get more elaborate information. Right now, just to remember that this is the present input. Then what is the past input? Let us say x of t minus 1, comma, x of t minus 2, x of t minus 3, and so on and so forth. These are called. So means that, are you observing? X of t is nothing present time, whereas x of t minus 1 means this is the past time input. This is the input with past input. Past inputs. These are the past input. You only remember that. Minus, if you use the minus sign, that indicates the past input. On the other hand, same applicable here also. Means y of t minus 1, let us say, for your understanding, y of t minus 1, y of t minus 2, and then y of t minus 3 and so on. So if you take different values of output y of t with t of minus 1, t of minus 2, t of minus 3, these are called past outputs. These are called past output. Past outputs. Past, not fast, it is past. Previous, you can say previous. Okay, past outputs. These are the past inputs. These are called, all these values are called past inputs. Okay, past inputs. Then say on the other hand, if you consider the plus values, if I consider x of t plus 1, let us say x of t plus 1, x of t plus 2, x of t plus 3 or t plus 5, whatever it is, you can take any value. If you consider the plus values, those are called future inputs. So these are called future inputs. These are called future inputs. Similarly, the case with output also means that, let us say y of some t plus 1, some y of t plus 10, let us say, whatever the value you take, plus, if you consider the plus value, these are called future outputs. These are called future outputs value. This is what the meaning. Therefore, as per the definition of the static system, your output y of t should depend on the same instant of time. So y of t should depend on the same input at the same instant of time. Means that your y of t, what could be the relation? Means that here obviously you can say y of t is obviously directly proportional to x of t. That's it in general to understand. In general means present output, present input, not past input and future input. There should not be any t minus 1 value, t plus 1 values. There should not be. Okay, so this is what the condition. Otherwise means that if your output will depends if on any past input as well as the future input, then your system is called a dynamic. That's what dynamic means. Dynamic means it depends on past as well as the future. It depends on past input as well as the future input. Whereas the static means, so it depends on the present input at the same instant of time only. That is what the static actually. Okay, so I will explain you a simple example, that's thereby you can understand very clearly, right? I will just explain you. I think you have understood very clearly this definition, I hope that, but let us see one example so that you will very clearly understand. Let us say, for example, for your understanding, let us say example. So always the output, so in order to express the particular system's response or the nature of the system or the characteristic of a system, normally that will be defined in the form of equation or relation, the relation between output and an input, normally like this. Say for example, if my output y of t is equal to, is given like this, y of t is equal to some 2 into x of t, let us say my expression is this. For any given system, my output is, okay, 2 into x of t. This is what my output. Now tell me, so what kind of system is it, static or dynamic? Can you happily identify it? The present output y of t is always depending on the x of t itself. There is no t minus 1, there is no t plus 1, there is no past input as well as there is no future input, right? So y of t is the present output and this is what present input. Therefore, this is the example for the static. This system is called a static system. This is a static system. Understood? This is an example for static system. Clear? Then I will explain you one more example. Let us say, for example, one more example. Let us say for example, my y of t is equal to, say for example, here some t into x of t plus another expression is given, some 2 into x square of t, let us say this is another example. My y of t means my output y of t is equal to t into x of t plus 2 into x square of t. This is the expression I have. Now tell me what kind of the system it is. Just only you identify, you just recognize that in the given expression, is there any x of t minus 1, is there any x of t plus 1 values of there? If so, that is directly called as a dynamic system. If only you have x of t values only, here x of t you have no output expression is equal to, this is present input x of t, this is x square of t. So what is the wrong in that? It is the square, x of is square of the input. Does not mean that t of minus 1 or t of plus 1. It is not t of minus 1 or t of plus 1. It is x of t itself, but you are taking square. Present input, for the present input you are taking square. Clear? Overall, you will have the present input only in the given expression. Therefore, it is expression for static. This is also for this is also a static system only. This is also static system only, right? On the other hand, one more example I will explain you. This is also static system. Okay. Say for example, if I consider one more example, let us say another example I will explain you. Let us say y of t is equal to, say for example, it is some 5 into x of t, or let us say t plus 1, some 2 into x of t, let us say, plus 3 into x of some t minus 2, like that. Say for example, any example you can consider. Now tell me, my output is in terms of input is expressed like this. Now tell me, so what are the input values you have in this? Present input is there. In my output expression, we have present input. Along with present input, you have future input also. This is future input. Plus, is there no? This is called future input. And what is x of t minus 2? This is past input. This is the past input. Therefore, definitely it is not static. It is the example for a dynamic. Clear? This is the example for dynamic system. Dynamic. I think you understood well. What is the difference between a dynamic and a static? So normally, this kind of expressions you will expect in the GATE as well as UPSC's IES examination, especially in the prelims, as I explained you in the previous, presentation. As you have in paper 2 of your preliminary examinations of IES, in the day 1 examination, that's what under paper 2 you are going to attempt the overall, you have the 12 subjects under your UPSC's IES examination. Okay, in the paper 2, you are going to attempt the questions from all the 12 subjects, out of which signal system is also there. Therefore, normally you will expect this type of expression they will give you, and they will ask you that whether is it static or dynamic, like that. Therefore, let us do more examples. I am giving very less examples to you, and the rest part I am leaving for you all, because you need to practice, you need to do more and more. I want to give you the basic foundation, basic information, which is very much required for you to understand the concept of a subject. But the rest part, definitely you must do more practice. Obviously, I think it is sufficient for today's presentation. I hope that you understood this, and in the subsequent presentation, I will bring you another classifications of system with an excellent examples, right? So we'll finish off this presentation here, and we will meet in the subsequent presentation. Okay, see you. Have a nice day.